Ladies and gentlemen, come closer. Here is it with this amazing robot, Eva 3. Ladies and gentlemen, let's be honest. How many times your robot not work or doesn't meet your expectations? The attachment was too large or too small? Well, our robot doesn't have any of those problems. Now we're gonna show you how we build it.
From the beginning, we set goals to achieve namely a robust, resistant, efficient, and innovative robot to work sessions that were very.
But you will wonder how this robot was built. Well, first we start to create this strategy without losing sight of the FLL update.
In our last participation in the Worldwide Open, we established cooperation with a German team that helped us to understand the formula for calculating the effort of a mission. To get this, we made a quantitative evaluation of all the missions using the formula of previous effort. And thus, we identified which were the missions that required more effort and denoted less risk. Thanks to this evaluation, we determined to make 6 launches to more than 8 missions. That will mean a total of 4.
But dear friends, don't forget this amazing tool called Kahoot. You will love it.
And for those who were asking for it, this is our base. Ladies and gentlemen, you aren't going to find this product out there. You can see it is a considerably small base. For what? Gain the advantage of 5 points in each mission and 10 points in the crane mission.
Really?
After all, our base, now modified for national competition, is efficient, compact, balanced, square, small, and nice. It has 2 sensors and 4 motors. Hey, the engines almost forgot me! Well, there are 2 large and 2 medium engines. The medium ones are for the activation of the snaps, and the big ones, obviously, are for the robot mobilization. Now a small but important detail, the brick is movable.
Innovative! Oh Jesus, oh my gosh!
Cities, a movable brick to more easily remove the wires and battery, and why not, to also change the same brick.
Of course, here I have this attachment. It consists of an initial anchorage where all the more attachments we use come out, with a transmission that nobody else has, with 2 cards called the Universal Board. And it can be our attachment. It has a little RAM that allows to the bolting mission and a custom-made box for buildings.
Sure?
Yes, a custom box for the buildings, but also is divided in 2 parts. One is fixed and the other is not. The removable part remains to following 2 missions, and the removable inside in order to another snap with the same mechanism. Replace it and achieve another mission. This mechanism is made with pinion and rock. It is a very precious mechanism that allows you to solve them. In addition, it has only designed for removable and removable.
Wow!
But look, Mr. Youth, don't you see that this base looks very lonely with another attachment that keeps its company? Well, don't worry and congratulations! Here I have a great promotion. I give you this beautiful snap, easy to put on, and don't need coupling pin.
What?
It also has the ability to swing, safety factor, forklift, and bridge.
But expect, dear friends, neighbors and companions, this great promotion doesn't end here. I have the most important thing, programming, a fundamental part of our Eva 3 robot. To perform it, we use specialized blocks that calibrate the sensors and many controllers, my blocks, conditionals, loops, and variables. But that is not all. To simplify the programming, we decided to make a mega launch that can activate all the others. This mega launch makes it possible to save the activation time significantly, making it necessary to put a negative value because the motors are inverted to go forward.
For everything to go well, this incredible device must have an order. Well, I have the script. Yes, sirs, the script can be slipped, and thanks to that, it flies in a small area.
Gentlemen, but that's not all. I have the ñapa. That's a gift. Look, our robot has an almost perfect repeatability. Thanks to our incredible system of battery charging, it always allows you charge your robot and control the voltage and current of your battery. It is a power bank, a voltage amplifier, a digital multimeter, and an adapter for Lego batteries. What else do you want?
Obviously, if the whole team starts to make the strategy, we will not have enough time for the competition. That is why we call teams which will have jobs such as the construction of the robot, the strategy of the points, and the new attachments. To avoid that some had more information than the others, at the end of the session, we always had a meeting where all the teams explained what conclusion they reached.
We use two sensors, a color sensor and a gyroscope. The gyroscope helped us to specify the degrees of rotation of the robot, which helped us in its mobility. The color sensor indicates the intensity of the light reflected on an object, its color among other functions. In the robot, it helps us identify the color of each aided attachment, so it executes certain programming or another depending on the color.
Our team tests the reliability of our robot through various tests carried out in the different scenarios of the playing field, warranting a constant level in the robot's battery by means of a special charge taking into account its discharge curve. Some of them were simple changes in the centimeters of advance or degrees of rotation of the robot, although we always tried to make slight changes in the programming in the face of very exact precision failures. However, in the face of significant failures, the necessary changes were made. An example of a mechanical improvement made to our base robot against such tests could be the example of the color sensors positioned on the front of the robot, which prevented the bridge from rising. Because of this, and after a team discussion, we decided to remove them.